and this is your in plane. Okay. Then we're going to draw the circle for YZ. Okay, so we're going to draw YZ circle. All right. So this is for your YZ plane, and this is your out of plane. And you realize now, or we realize now, that it's not the biggest circle, yes or no? Right. So over here, this is for your tau max YZ. Okay, so it's not so this one is your out of plane. Okay, and finally, the last circle that we need to draw. This is for your, I think by now you should have no problem recognizing which circle is for which plane. This is called XZ plane because it touches point X and point Z, and this is your out of plane. Okay, and this height over here. Right, this is your tau max for your XZ, and this is your out of plane. Okay, so for this case, the formula is not like or the condition is not the same like before. So tau max, okay, tau max is equal to tau max xy, which is equal to tau max yx, right? And this one, the formula is equal to what? Stress y minus by stress x divided by what? Divided by 2. Okay, so we realize that the maximum is what? In plane out. So the formula is not the same like condition number 1. Okay, and we know that stress y for this case will be your stress max, or stress max will be your stress y. And the stress mean will be equal to your stress x, right? So the shear max is equal to, okay, is equal to stress max minus by stress mean divided by 2. Okay, so that is condition number 2. And lastly, for condition number 3, do I have enough space? Yeah, I think I have enough space. Wait. Yep, I do have enough space. So the last one, okay, you'll be squeezing a bit, but you guys will get the idea. Is more important is the formula that I'm going to write up. So this is condition number 3. Okay, condition number 3. So condition number 3 is where stress X is less than stress Y and is less than stress Z. And or stress Z is greater than stress Y, greater than stress X, and all are positive. Okay, so I'm not going to draw the element. You guys will know how the element will look like now. Okay, so for this condition over here, so I'm just going to focus on the positive. Okay, so just focus on the positive. So we have our stress X. And then we have our stress Y. Then we have our stress Z. Okay, so this is our stress X, stress Y, and then stress Z. Okay, and this will be our point X, point Y, and point Z. So we know that now we can construct 3 circles. Okay, so this is our XY plane, our in plane. Then the next one we can construct is our YZ plane. So again, we can see that the in plane is not the, right? It's not the, so this is out of plane. Oh, sorry, in plane. This is our out of plane. Right, now the bigger circle is our YZ, okay? And it's our out, sorry, XZ. So this is our out of plane, okay? So we know from here, what we can see from here is the tau max is the tau max on your XZ plane, which is equal to tau max of your ZX plane. So that's the maximum now, right? So this is like what we said before, this is out of plane. Okay, this is out of plane. And tau max in the XZ plane is equal to stress max or stress max, right? Stress max minus stress mean divided by 2, which is equal to stress Z minus by stress X divided by 2. Okay. So that is condition number 3. Okay. So this one, the tau max is out of plane. Okay. So that is, and now that's all the theory there is in 3D Mohr circle. So we are going to work on one example. Okay, we're going to work on one example. So this example we're going to work on, okay, is going to be, I've posted on Avenue to Learn. Okay, so hold on, I posted on Avenue to Learn. Okay, I've posted on Avenue to Learn. Okay, this example that we are going to work on. Okay, so it is this example. So I've just moved something. Hold on. Right. So this will be your page 5. Okay, so this example over here you can see is a 3D element. So if you could download from Avenue to Learn, okay, you could see this example on Avenue to Learn. You can see there is a 3D Mohr circle. Okay. For the stress state shown, determine stress for Y. For the maximum shearing stress is 75 megapascal. Okay. I have also posted the solution. So this is the solution. Okay, this is the solution. And it's just a bunch of black boxes. Okay. You don't know what, I mean, okay, not we, okay. I don't know what is trying to tell me. Okay, so if you see solution like this, okay, if you want to do this, good luck. Okay, this is done by someone that's mathematically strong. Okay, their mind about the rules of the circle is very strong. Okay, and I'm not at that mindset. Okay, I'm not at the mindset to derive all this equation. I'm going to teach you an easier method. And it's basically all we're going to use is what I taught you since 9 o'clock to now. Okay, without trying to figure this thing out. Okay, but an important thing to take note is this. What are important? So important thing are some of these values. Okay, so you will see this is what they say that. Oh, let me highlight. Okay, they say that this is a rejected value. Okay, we don't know why, or for now. Okay, then they mention that what else? The values that are possible. So this is a where this is a wait. There's a yeah. I think I will stop trying to figure out what they're trying to say. Okay, so there are terms down here why there's a reject and why there's no reject or whatsoever. Okay, so I don't want to figure out what they're trying to do. We are going to do this based on what I've taught you. Okay, and not based on what the solution is providing. But the final answer is important. Okay, we're going to find out why they call that reject. And we're going to find out, okay, they say this value is okay. They say later on, they mention that there's a value down here that is 50 is okay. Okay, so we're going to find this out what is going on. Okay, right now, we are going to do just by using our own technique. Okay, simple and fulfilling, not something that is complex like what they are doing. Okay, so if I show you how simple it is, you guys will be laughing, I hope. Okay, right, so this will be our example number 3. Okay, there is our example number 3. So for this example, right, I'm going to do something extra for you over here. Okay, so they mention that we're going to find possible stress Y values. Okay, and they say there are 2 possible stress Y value. They mention that tau max, the maximum shearing stress, is equal to 75 megapascal. Okay, so when they say that, so this is, so it cannot go beyond 75 megapascal. Okay, so this is basically what we call the shear stress criteria. Okay, and the shear stress criteria, okay, is also known as Tresca criteria. Okay, and Tresca, I spell it this way. You see the letter down here, right? So Tresca spelling is Tresca. I changed the T to tau, so it will help me remember that it's based on what? Shear stress. Okay, right? Shear stress is that symbol over there. So I change it so I know that is shear stress. Okay. So from here, what does this actually mean? Okay, we know from the element that stress Z is equal to what? 0 megapascal. Right? We know that. Okay. So if I'm going to briefly sketch in 3D, I'm just going to draw the bigger circle. This is our normal shear stress. This is our normal stress. We know that point X will be, sorry, point Z. Okay, Eugene. We know that point Z will be here. And knowing that tau max is 75 megapascal, we know the other extreme point has to be what? 150 megapascal. Right? Because why is that? Because of the rules of the circle, yes or no? Right? So we are given the what? If we are given the radius, right? So we know that this is equal to what? This is equal to 75 megapascal. We know that this material can only take the maximum stress of 150 megapascal. So therefore, all right, the normal stress max is equal to twice the radius of the circle, right? Twice the radius of the circle, which is equal to plus or minus 150